All right, today I'm going to talk you through hydrolysis reactions. These are the two you'll actually have to know for the quiz. I'm running out of time and I have to take care of babysitting responsibilities of my babies, so I'm only going to give you two. So these are the two you'll have to know for the test. Proteins are chains of amino acids connected by carbon-nitrogen bonds. Note that there is no oxygen holding the monomers together in an amino acid chain. And in an amino acid, one side is capped with a hydroxide, OH, hydroxide because hydrogen and oxygen, hydroxide. And the other side is capped with a hydrogen. Then there are water molecules. In a hydrolysis reaction, the water molecules are used to break apart those bonds between amino acids so that we can get them down to monomers, reorganize them, and use them for our own intents and purposes. So, here are amino acids broken up by the water molecules. I'm drawing red dots to show valence electrons that are now available for bonding. So, where those two electrons used to be bonded together, now that has been broken. And where hydrogen used to be bonded to hydroxide to form water, that bond is now broken, which means that there are valence electrons ready to bond elsewhere on all of these endpoints. Where they bond together is dependent upon which side of the chain you start on. Since we're starting on the hydroxide side, the other cap on the other end of this amino acid must just be the hydrogen. So they'll be bonded there. Because we've used the hydrogen from this water group to bond there, what we have left is hydroxide, so a hydroxide will bond right here. There's its valence electron, there's its bond. Note that I've shown oxygen bonding to that amino acid. Hydrogen's already formed one bond with that oxygen, it can't bond anywhere else. And the same thing applies here. Hydrogen bonds there because this side has an OH, so this end can only have an H. And oxygen bonds there. That's the hydrolysis reaction. The dehydration reaction is the exact opposite. You would start at this end with individual monomers of a polymer, and your arrow would go the other way. And the hydroxide bond would be severed with this amino acid, and the hydrogen bond would be severed with this amino acid, and they would be free floating like here. Then you would go one step further back, and water molecules would reform, and your polypeptide chain would reform because these electrons would now bond back to each other, and these electrons would now bond back to each other. So, a dehydration reaction is just a hydrolysis reaction in reverse. You could even write that on the quiz tomorrow. If you fully articulate what's going on here, I know that just saying it happens in reverse, you understand what is going on with electron movement, and so that would be sufficient. The other one you have to do on the quiz is lipids. Here's our glycerol molecule, or our triglyceride. It is a glycerol bonded to 3 fatty acids. The difference is these 3 all have oxygens holding the fatty acids to the glycerol. And so what we're going to do is we're going to insert water molecules. These water molecules are blue because water is perceived to be blue because of the sky. And so what we're going to do is break bonds accordingly. So our glycerol will now have empty valence electrons where it used to be bonded to the oxygen. So we'll break these bonds. And here we'll have oxygens with free valence electrons because they used to be bonded to that glycerol. This used to be a bond, but we've now broken those bonds. And the same thing for our water molecules. Where once we had H2O, now we have OH and H's. Note that because oxygen is already here, we will not bond the hydroxide to the oxygen, we'll just bond the hydrogen to the oxygen. And so those valence electrons will form bonds with each other. The hydroxides will bond to the glycerol, the hydrogens will bond to the oxygen. And that will be shown here. Fatty acid, fatty acid, fatty acid. And there are those bonds being formed. Note that H and showing the bond between H and O is the same thing as writing O and H together. It is assumed that that H is bonded to that O. it is explicitly stated that this H is bonded to that O there, but they are the same. And so then just to clean it up, I'll show you the way you've seen it many times before is a glycerol with hydroxide caps where the 3 fatty acids used to be, and each fatty acid having a hydroxide cap as well. All right, those are the two reactions you'll need to know for the quiz tomorrow. Those of you that are watching this, tell your friends so that they are then in the know as well.